Let's look at some misconceptions while students solve problems in algebra. First one, we know that b whole power m is equal to a power m into b power m. So b whole square will become a square into b square from this rule. But what about a plus b whole square? A lot of students write this as a square plus b square, which is wrong. A plus b whole square is equal to a plus b into a plus b. So this is a into a plus a into b, that is a square plus ab, plus b into a plus b into b, that is b into a is ba plus b square. So that will be equal to a square, this ab plus ba, both are ab, so that will be 2ab plus b square. So you see that there is a third term 2ab when you expand a plus b whole square. So you cannot write a plus b whole square as a square plus b square. This is not correct. So this is the first one. Second one, square root of ab is equal to ab whole power 1 by 2, because we know nth root of a is equal to a power 1 by n, which means cube root of a will be equal to a power 1 by 3, or square root of a, when there is nothing in the place of n here, it is implicitly assumed to be 2 square root. That will be equal to a power 1 by 2. Therefore, square root of ab will be equal to ab whole power 1 by 2. This will now be equal to a power 1 by 2 into b power 1 by 2. This will be square root of a into square root of b. But what about a plus b square root of this entire thing? Can I write this as square root of a plus square root of b? This is not correct. In the same breath, if you say cube root of a plus b is not equal to cube root of a plus cube root of b. This is also not correct. Okay. And again another one, a square plus b square, the square root of this entire expression. Is this equal to square root of a square plus square root of b square? No, this is not correct. Okay. So the square root of a square plus b square will remain as a square plus b square whole power 1 by 2. So this is one more common misunderstanding. Let's now go to algebra based questions that students go wrong with. Let's look at the three basic forms of equations. First one is something like 5x minus 4 is equal to 3x plus 10, where there are no fractions on either side of the equals to sign. Now this is very simple. Bring all the variables to one side, preferably to the left hand side, and all the numbers to the right hand side. So that will become 14. So this will be equal to 2x is equal to 14. And you can solve x is equal to 14 by 2, 7. Second basic form is p by q is equal to r by s, where this division symbol is for the entire numerator in the LHS, and this division symbol is for the entire numerator in the right hand side. What does that mean? If I take an example like this, x minus 4 by 3 is equal to x minus 5 by 6. What can I do when the equation is in this form? I can cross multiply. P into S is equal to R into Q and then solve the equation. So in this case, I can write this as 6 into x minus 4 is equal to 3 into x minus 5 and solve. Now you can observe that it is now again back to the first form, where there are no fractions on either side of the equals to sign. The third one is where you have fractions. Let's say x by 3 minus 5 by 4 is equal to 2x by 3 plus 2 by 8. So you have more than one term in LHS, more than one term in RHS. What we have to do is firstly convert this to the second form. That is, bring this to the form P by Q is equal to R by S. For that, you take LCM on both sides like this. 12 is the LCM. This will become 4x minus 15 is equal to 24, 16x plus 6. Now this is in the form of P by Q is equal to R by S, where this division symbol is for this entire 4x minus 15, and this division symbol on the right hand side is for the entire numerator on the RHS. Okay, so now this is in the form of P by Q equal to R by S, so I can do cross multiplication and then solve. After looking at these three basic forms of equations, let's look at some of the common issues that we encounter. Example, let's say 3x minus 4 by 2. If there's a fraction like this, how do you simplify this first? Can I write this as by striking off 4 and 2 like this, and can I write it like this, 3x minus 2? I cannot do this, because when I have 3x minus 4 by 2, this division symbol is for this entire numerator. That means if there are multiple terms like this in the numerator, more than one term in the numerator, then this division has to be applied to all the terms in the numerator. That is 3x by 2 minus 4 by 2. So this is the right way to simplify that expression. This will be what? 3x by 2 minus 2. You can see that these two are different. So you cannot write it like this. This is wrong. Okay, the next one, 6x, a similar one, 6x minus 7 divided by 3. Can I strike off 6 2 times and then write this as 2x minus 7? This is not right, because 6x minus 7 by 3 is equal to, I have to apply the division to both the terms in the numerator. If there are more than 2 terms also, I have to apply this division to all the terms in the numerator. Minus 7 by 3. This is the correct one. Next, if 3x minus 4 is equal to 2 is equal to 2x plus 5 divided by 3, all for x. Then you cross multiply and say 3 into 3x minus 4 is equal to 2 into 2x plus 5. But if I have 3x minus 4 and then this division is only for 3x, and on the right hand side I have 2x by 3 plus 5, then can I say 3 into 3x minus 4 is equal to 2 into 2x plus 5? This is wrong. Firstly, I have to take LCM. That is, I have to take LCM on the left hand side like this, and then on the right hand side also I take LCM and ensure that this division symbol is for the entire numerator like that for all the terms. On the right hand side also this division symbol should be for the entire numerator like that. Then I can do cross multiplication and solve. Now this is in the form of P by Q is equal to R by S. So I can cross multiply. Similarly, if I have 3x by 2 minus 4 is equal to x, can I write this as 3x minus 4 is equal to 2x? I cannot write this like this. 3x by 2 minus 4 is equal to 2x means I have to firstly convert this entire left hand side into a single fraction by taking LCM. That is 3x minus 8 by 2 is equal to 2x. Then I can say 3x minus 8 is equal to 2 into 2x. Then I can easily solve this one. Or when I have something like this, I can write this as 3x by 2 minus 2x is equal to 4. I take the number part to the right hand side and bring 2x to this side. Then I can take LCM again. 3x minus 4x by 2 is equal to 4. That is minus x by 2 is equal to 4. And I get x is equal to minus 8. Next one. when I have 5x by 3 is equal to 2x by 5 minus 7. Can I write this as 5x is equal to 3 into 2x by 5 minus 7? This is wrong. When I take 3 to the other side, to the right hand side, I should write that as 5x is equal to 3 into, I should implicitly assume there are brackets around the entire RHS. Then I should multiply the entire RHS with 3 when I take 3 to the right hand side. 2x by 5 minus 7. That means 5x is equal to 3 into 2x by 5, that is 6x by 5 minus 3 into 7, that is 21. Now I can solve. For right hand side also, I should take LCM first and then convert this into a single fraction, that is 6x by 6x minus 105 divided by 5 and 5x. And now I can take this 5 and multiply the entire LHS and then solve. So this will become 5 into 5x is 25x is equal to 6x minus 105. So now this is in the simplest form. You can bring 6x to the left hand side and solve for x. Next one, 3x minus 2x minus 5 by 2. Can I write this as equal to 6x minus 2x minus 5 by 2? This is wrong. This is equal to 3x into 2 minus, because there is a minus symbol, you have to implicitly assume there are brackets around this expression and apply minus to all the terms inside the brackets. That is minus 2x minus 5 in brackets like that, whole divided by 2. That will become 6x minus 2x plus 5 whole divided by 2. You can see that there is a difference between this and this. So this is correct. Next, 5 divided by 2x minus 5 by 3. 5 whole divided by 2x minus 5 by 3 is equal to 7. Can I write this as 5 divided by 2x minus 5 is equal to 7 into 3? This is wrong. So the principles are, when you have a rational number with fractions in both numerator and denominator, p by q divided by r by s, this is equal to p by q. This division symbol, convert that into multiplication symbol and take the reciprocal of the fraction in the denominator, that is s by r. So this is the first one. Second one, if I have a fraction in the numerator but only a number, you write this as p by q, convert the division symbol into multiplication symbol, and this r is nothing but r by 1. So take the reciprocal of that and write it as 1 by r. So this becomes p by q into r. Okay, and similarly this becomes p into s by q into r. So the third one is, I have a number, whole number in the numerator and a fraction in the denominator like that. This is equal to p, and convert the division symbol into multiplication symbol, take the reciprocal r by q. This is equal to p into r by q. So these are the rules that govern the conversion of a rational number with fractions in numerator and denominator into a single fraction like this. So this means this will become 5 into 3 by 2x minus 5. Of course, put brackets around 2x minus 5 is equal to 7. That means this will become 5 into 3 is equal to 7 into 2x minus 5. Okay, so you should not write it like this. This is wrong. Next one, cancelling terms during addition, subtraction and multiplication, division. Addition, subtraction, cancellation of terms during addition, subtraction. Let's take an example. If I have a cyclical expression like this, a square minus b square plus b square minus c square plus c square minus a square, what would this give me? This is equal to this a square minus a square will get cancelled, minus b square plus b square, c square minus c square will get cancelled. All the terms are getting cancelled. This will give me 0. So this is in case you are cancelling terms in addition and subtraction. In case of multiplication, division or division, let's take an example. 25x square by 5xy into 5y square divided by yx. So how will I cancel terms? This is a multiplication symbol between these two fractions. So if I want to cancel, how will I cancel? This 5 and this 5 I can cancel out, right? And this x and this x is x square. This will cancel out x square in the numerator. This y and this y will cancel out y square here. And assume that I have one more 25 here. If this 25 cancels this 25, every term is getting cancelled in the numerator and denominator. This will give me 1. So essentially this is the difference that you need to understand in case of cancelling all the terms during addition, subtraction or multiplication, division. Let's look at some more examples. A by b into c by d is equal to a into c by b into d. This is to convert this fraction multiplied by this fraction into a single fraction like this. So as an example, 2 by 3 into 9 by 10 is equal to 2 into 9 by 3 into 10. So this goes into this 9 3 times, and this goes into this 10 5 times. So this is equal to 3 by 5. Applied to algebraic terms, 2x square y square by 3yz into minus 9yz square by 10xy is equal to 2x square y square by 3yz into minus 9yz square, like that. I have to assume there are brackets around that 9yz square term, even if it is not given in the problem, but divided by 10xy. So this will make it minus 2x square y square into 9yz square whole divided by 3yz into 10xy. So this will be minus, if I divide 9 by 3, I get 3 in the numerator, and in the denominator I get 5. So this will be minus 3 by 5 into, this is x square divided by x, this x square divided by x. I get 1x in the numerator, and this y square by y square, this will get cancelled, so that will get cancelled, but there is one y here, I'll write one y in the numerator there, and this z square divided by this z will give me 1z in the numerator. So this will be minus 3xyz divided by 5. P into Q whole divided by R is equal to, I can write this as P by R into Q, or I can write this as P into Q by R. All these are equal, but they are not equal to P by R into Q by R. I cannot apply this division by R to both P and Q, because the symbol between P and Q is a multiplication symbol. So this is wrong. But if I have something like P plus Q by R, I should write this as, I should now apply this division symbol to all the terms in the numerator, that is P by R plus Q by R. Let's take an example of numbers. 9 into 15 plus 3 by 3. Let's say this is like this. This is equal to 9 into 18 by 3, that is equal to 162 by 3, 54. You can verify this. If I say this is now equal to 9 by 3 into 15 plus 3 equal to this 3 goes into 9 3 times, 3 into 18, 54. Or I can also say this 9 into 15 by 3 plus 3 by 3, that is also fine because I am applying this 3 division by 3 to this whole thing in the brackets. Then I can write this as 9 into 5 plus 1, that is equal to 9 into 6 equal to 54. That is also fine. But essentially I am applying this division by 3 to either this one or this entire expression in the brackets, 15 plus 3. But only once. I cannot say this is 9 by 3 into 15 plus 3 by 3. No. I apply this division to either 9 or 15 plus 3. But when I apply this to 15 plus 3, I should apply to 15 as well as 3, like that. Next example is if I have something like 15x square plus 9x by 3x. This would be 15x square divided by 3x plus 9x by 3x. So that will give me 5x plus 3. I have to apply this division by 3x to this term as well as this term because the symbol between these is plus. But if I have something like 15x square into 9x by 3x, I can write this as 15x square by 3x into 9x or 15x square into 9x by 3x. This is 5x into 9x or this is 15x square into 3. So that gives me 45x square here. Same thing here for 15x square into 3. That gives me 45x square. But I cannot write that as 15x square by 3x into 9x by 3x because the symbol between this 15x square and 9x is a multiplication symbol. I shouldn't be applying this division by 3x to both 15x square and 9x. So the rules have to be applied consistently to avoid these mistakes.